Hello again, you sick, twisted weather freaks, and welcome to another fun filled, action packed, and intellectually stimulating edition of This Week in Weather. I'm your host, meteorologist DT from weatherist.com, your professional mad scientist, the commander of chaos, the colonel of confusion, the captain of catastrophe. Let's talk this week in weather, and then more weather after that. So let's get right to it. Topics today on this edition, we'll talk about, it was a cold November. November's over, and it was pretty darn cold. The return of some semi-Arctic air. We have a minor event in the Mid-Atlantic, maybe December 6th. And then the potential bigger snowstorm or winter storm December 8th or 9th. And then the breakdown of the cold pattern December 12th, maybe out to the 24th of December. So let's get right to it. There's a picture of my smiling face from Richmond, Virginia. And then you can see my email there to different Verizon at Gmail. There's the Twitter page, and there's the Facebook page. All right, this here is November. And you can see that for the month it was pretty darn cold. And you can see now the really cold temperatures relative to normal for the whole month was really centered west of the Appalachian Mountains. I mean, if you look at that white stuff in the middle of the green, that's 8 degrees Fahrenheit below normal over Missouri and portions of Illinois, and then 7-8 degrees over Minnesota, Iowa, Wisconsin, eastern Kansas, eastern Oklahoma. Now, once you cross the Appalachians, notice that we're in the light to dark blue, so 2, 3, 4 degrees below normal. Still pretty cold for the month, but the real cold was centered over the Midwest there. No doubt about that, into the lower plains. Now, if we take a look at it regionally, this image here shows us where November, the mean temperature placed out of all the Novembers, since we have weather records go back to in 1880 or 1870 or what have you. Now, you can see that over the Piedmont and the coastal areas, it was moderately cold November, but the blue colors represent either the top 10 or the top 5 coldest Novembers on record. So, for example, if we were to take a look at, Blacksburg, for example, November 2010, around the 10th coldest November on record. Charlottesville, 10th coldest on record. Uh, Winchester, 6th coldest on record. Hagerstown, 4th coldest on record. I'm not making this up. I don't know if that's Dulles or what have you. It might be the 10th coldest on record there. And then, of course, in the mountains of western North Carolina, southwest Virginia, the Shenandoah Valley, it was cold everywhere. So, yeah, it was a cold month for November. There's no doubt about that. All right, this next image here shows us the same map, but it's for the northern Mid-Atlantic into New England. And look at all the areas which for November placed in the top 5 or top 10 coldest Novembers on record. It has been a cold, cold November. And the problem is that these are almost December temperatures. So you think that temperatures are in the 40s, which is like December temperatures, and you don't realize that the normal high temperature in the beginning of November is in the low to mid 60s, and in November is around 55 to 60 in the Mid Atlantic region. So it's been a shock, no doubt about it. All right, this here is the current Saturday late morning midday weather map. There's our big low pressure over Kansas. This is a big rain event for everybody outside of the Dakotas, Minnesota, Nebraska, northwest Iowa. And that's going to move up eventually into the Great Lakes and up into eastern Canada. But as it does so, it's going to pull up a lot of warm air. And if we get any sunshine tomorrow at all in the Mid-Atlantic region, many of us are going to break 70 degrees, maybe even 75 degrees. Excuse me. Now, after that goes on through, so here's our GFS map. We'll use the GFS F3 for this. You can see the lows up in southeastern Canada. The cold front starts to come in on Monday night, Tuesday morning, and then the front finally pushes through on Tuesday. Big cold high coming down over Oklahoma. Strong north winds, so the Arctic air returns. All right. Let's talk about December 6th. Now, a couple of days ago, this looked like it might develop a wave on the front. It might bring a period of steady snow to Virginia, North Carolina, maybe Tennessee, that sort of thing. Now it looks a little different. It's not quite as impressive, but the upper level energy is. So these two maps here show the upper level energy on the evening of December 4th and December 5th. And you see, let me point out what I'm looking specifically here. This feature here, see that? That's a disturbance or a short wave, a vortmax in the energy there, in the jet stream. And look what it does. See how it passes right over Virginia, central Virginia. So that's one of them on Tuesday night to Wednesday morning could bring snow showers. Right, not a big deal, but snow showers. Don't be surprised if you see some as the Arctic air returns. Then the other one is this one. Now this is a much stronger system. on the Wednesday evening, December 5th, Wednesday afternoon, and you can see the model actually, believe it or not, on the European, actually closes this baby off. This is a very strong Vortmax here. And I would, I think the short range models are underdoing here. Of course, this is 114 hours out, so it's not really showing up. It's mostly still in the global models. But don't be surprised if the short range models, as we get closer, if this feature holds together, starts showing several snow showers or snow bands over Virginia, Maryland, Delaware, West Virginia, Eastern Kentucky, maybe northern North Carolina. That's a pretty strong shortwave that tracks right over the area. So that's going to drop some snow showers on some people on Wednesday afternoon. Do not be surprised if that happens. And with the arrival and return of the Arctic air. Okay. So that's December 6th event. Now that moves out to sea. The cold air comes in, and you see that system here off of California. Look at that big low off of California. That's the next storm we have to worry about. Okay. Now last week, okay, let's talk about December 8th and 9th. Oops, let me clear this out here. There we go. There we go, December 8th or 9th. And that we talked about this last week. The last episode I did of last week, This Week in Weather, I showed this on the European Ensemble, which showed a pretty deep trough over the Northeast and the potential trouble. And sure enough, that's looking like what's coming. Now, this is the European Ensemble from Thursday. So I wanted to show you how this is developing here. So this is the ensemble. We're not looking at the operational run. We're looking at the ensemble mean, which consists of 50 different members of the European model taken as a mean. So the main shortwave in the southern jet stream is this feature right here. Okay? And notice the black line, see how it's almost neutrally tilted. It is due north to south, right over the Mississippi River. That is textbook perfect position for the southern shortwave to develop into a coastal storm. Doesn't mean it's going to happen. That's just what the model's depicting right now. Now, the squiggly line over Western Canada, that's your ridge, and we have a supply of cold air coming in. And the image on the right, that's the surface map. So see the purple line? That's the rain-snow line. So you can see it's on the Virginia-North Carolina border. And the cold high is over Iowa near Chicago, driving the cold air in. So this is a pretty cold setup, even into North Carolina for early December. That's pretty impressive, I think. And now this was the GFS. Again, this is Thursday's GFS. So it's been on the GFS model has been jumping on this for a while. You got to give the GFS model credit here. It's seeing this just like the European is. And you can see the low moving on the Georgia, Carolina coast. And notice the heavy snow, according to that model run, doesn't reach north of Washington, D.C. That doesn't mean that's going to be the case. That's just what the GFS was showing back on Thursday, okay? Just letting you know. And you can see two big highs, one over New England, the other one over Iowa, and feeding a classic lower middle Atlantic snowstorm, and potentially ice storm as well. Okay, now, back in 2008, Dr. Heather Archambault and Lance Bossart, they did a study on the relationship between the teleconnections going through big changes and big precipitation events during the cold season in the northeastern U.S. Now, she's moved on to, I believe, the Naval Research folks, and she's on the West Coast, but it's a very important paper and it's significant. What we also found out, it's gone beyond just the NAO or the PNA changing. It's also, or the Arctic Oscillation. It's gone on to other teleconnections. So what I'm showing here is these are the teleconnections on this image. Now the map on the right shows you where they are. So let's take a look at this carefully. So the PNA, as we've talked about before, right here. Well, let me call this image. You can see it better. There we go. There's the PNA. Now that refers to the ridge in Western Canada. So right now it's positive, and you can see it right here. It's positive right in this early December. Now look what happens around December 6th or 7th. There's a phase change here, and it goes negative, which means the trough comes into the West Coast. But it happens right before potential East Coast storm. Phase change. Look at the NAO. Again, the NAO here over Eastern Canada, the Greenland block, as we refer to it. Now we have the NAO negative, and then right till you get to December 7th, bam, phase change coming up here. See that? So again, that's the significance of this, is that when you get these patterns setting up and you have a phase change, and then you get several of them lined up, it can mean something significant. Now the EPO, let me call up that one. Of course, that's over here. Oops, wrong marker. There east over Alaska, and that's when the ridge from Canada extends up into Alaska when the EPO is negative, which is what it is right now. We get a cold air supply. But look what happens. We get to December 9th, 8th, boom, it collapses, and then it goes positive. So each one of these goes a phase change from negative to positive, positive, negative, as we approach December 6th, 7th, or 8th, right before the East Coast storm, potential East Coast storm. That's what's significant about it. Look at the Arctic oscillation. Okay, here we are. Now the forecast, we're looking at the green lines, which is the ensemble mean. So we're negative, near neutral, December 6th or 7th, and then bam, after December 9th, it takes off, goes positive. Phase change. That's one way of looking at it. Okay, this here is the European ensemble from this morning, and we can see a couple of really nice features here. First, here's our polar vortex. Very clearly, you can see that sucker sitting there right very nicely where it should be. Here's our ridge on the west coast, driving in the cold air. You see the ridge right here? There you go. And it's driving in the cold air. No doubt about that. Nice, strong flow of cold air coming in. The ridge goes up to Alaska, so the EPO is getting some Arctic air coming in here as well from North Pole. So that's good. But look at this feature in the southern jet stream. You see how the jet stream is split? See how the yellow lines go here and the green lines go here? That's what's known as a split flow. Classic split flow pattern. You love them for East Coast snowstorms, especially the ones which come out of the Gulf of Mexico, like this one's going to. So this is a classic split flow pattern. Northern, see how it splits? There you go. Now that's the feature we have to watch. Okay, so let's go to the next one. Now, here is 168 hours. Now, the southern shortwave is now moved from the west coast to here. See it? Okay, so the low is probably somewhere like this. And again, we still have our ridge here and the southern system there. Big split flow, cold air coming way deep into the country, the New England. There's our polar vortex fairly far to the south. There's our negative NAO. So things are looking pretty good. Now, here is 192 hours. This is the time of the storm. This would be next weekend. And you can see the short wave very clearly, the southern stream right there, some sort of low pressure here. And there's our northern branch bringing the cold air in. And that produces the potential winter storm. There's your low pressure area, just in that area. That's the idea behind it. Now look, there's another big trough in the Gulf of Alaska coming in as well. But in any event, then as this is the GFS parallel model. Now, what's for Sunday as well. Now, notice what happens here. In all of these models, what's significant is that the northern branch does not come in or phase with the southern branch. Let's look at the GFS ensemble. So here's the green. We talked about the green line showing the northern branch. See how it does this? It is, and there's the southern branch doing that. Notice the green lines are not dropping in here. They're not fully phasing. They're staying to the north, which keeps the cold air in place, but you're not getting a full phase, so the low pressure area does not come all the way up the coast. It does one of these things because it doesn't fully phase. Now, it might change. This might change later on, but as it stands right now, it doesn't fully phase, and that doesn't pull the low all the way up the coast. So we can see that on the GFS parallel. And it also shows up on the European. Let's take a look at this one. You can clearly see the northern branch, the green lines, coming into the Great Lakes and then across New England, but they're not dropping in. We're not seeing that. We're not seeing that. There's two separate streams, and they only partially phase. Now, outside of weather models, there are other ways of looking at this as a possibility. Here is the MJO, the Maddie and Julian oscillation. And as we talked about in the newsletter, what, you don't get the newsletter? Why? You should be getting it. It's only $5 a month. Anyway, if you're getting the newsletter here, you would saw this earlier, but this is the MJO phase 1 in the month of December. This is a snowstorm pattern. You can clearly see the low coming out of the Gulf of Mexico and bombing out or developing off the mid-Atlantic or New England coast. There you go. That's what that looks like. So that's another reason to believe it. Now, let's talk about showing snow maps from weather models at day 7, day 8, day 9. A lot of people don't like doing it. A lot of people do this. So this is my perspective on it, all right? There is a difference between these two examples. Someone that uses Twitter or Facebook, let's say has the handle Weather Weenie King Snow Dork, all right? Whose actual job is running the burger machine at Burger King. And he's posting the snow maps, okay, for 180 hours out. uh, from the GFS model, one of the GFS ensembles. And then he insists he's got a secret formula that shows the 12 inches is actually going to be 31 inches at his house. That's nonsense. That's the type of post you should ignore. It's you're not dealing with a meteorologist. You're not dealing with somebody who's even dealing with reality. So those are going to be out there. Just ignore them. The second example is where a professional meteorologist who's well known, experienced, posts the same snow map, but he also posts other snow maps to show you what the trends are, the uncertainty is, what the possibilities are, that sort of thing. So those are two different examples. They're both showing the same snow map, but it makes a difference who's showing it and why and what the purpose of it is. Okay. Hopefully you all agree with that idea. All right, let's move on. Okay. This image here is, again, classic snow maps from the European model. This is from Friday and Friday afternoon. The European model Friday morning had the storm mostly inland. And then it came a big snow for central and northern Virginia and Maryland and West Virginia and Philadelphia and New York and New Jersey and so on and so forth, Long Island. Now, either one of these solutions might be viable, but this just shows you there's a lot of variability here. Now, this is the new Saturday morning European operational run. And notice it's got the heaviest snow, that pink stuff, 10 inches, in southwest Virginia and northwest North Carolina. And then the rest of Virginia Piedmont up to DC sees several inches of snow. And then once you get south and east of Richmond, it's mostly either sleet or rain. If you look at the ensemble mean, there you go, same sort of thing. Good snow, several inches, not a monster snow in the ensemble mean, but again, this is 50 models taken as a mean. And the reason for that is we can take a look at it. Here was the first 25 models of the European. So if we look at some of these, let me show you what I'm talking about. See this map right here? That solution shows no snowstorm at all. This one has a snowstorm for Northern Virginia, DC, Philly. This one's for Central Virginia. Same as that one. This one shows a solution for North Carolina. This one has the snow all to the north, and so on and so forth. Same thing, North Carolina. This is a complete miss. This is a big snowstorm for I-95. This is a big snowstorm for Central Virginia. This is a big snowstorm for everybody. So all these different possibilities. So this is just the first 25 of them, and there's another one, another section of the ensembles I can show you here. And this is, again, the black star, the asterisks in this image and this image show big snowstorms for Virginia and Maryland, big possible solutions of what might happen down the road. So there's a significant, about 25 of the 50 ensemble members are showing a significant snowstorm for Virginia, Maryland, Delaware, Philadelphia, New Jersey, West Virginia, what have you. It's a significant portion, but it's not a huge portion yet. All right, this here's the GFS from early this morning, and we can see what the GFS is doing for Saturday, December 8th. The purple line represents rain or snow, or the frozen precipitation line, I should say. So we can see here that the line is right through Richmond and down through Roanoke. This is all rain down in here in North Carolina, Southern Virginia, Tennessee, and then begins to turn colder. So by the evening of the Saturday, December 8th, the cold air is pouring southward into the Shenandoah Valley and pushing it south of Richmond. So this is all heavy snow in here and ice and that sort of thing. It still rained over Tennessee, Kentucky, North Carolina. And then this is the Saturday night, early Sunday morning, December 9th. Rain snow line is pushed south and east of Richmond. Most of Virginia, Maryland getting hammered at this point. So is Kentucky, Southwest Virginia, that sort of thing. And that continues. Even the GFS parallel run on Sunday morning has heavy snow on the Virginia, North Carolina border. Everything north of it is heavy snow up to DC and Baltimore. So that's one possible solution. Doesn't mean it's right, just one possible solution. And if we look at the ensemble mean, this is for Sunday, December 9th. You can see where the rain snow line is on this thing here, like in this direction here. So this is mostly rain and this is mostly snow. And again, this is Sunday afternoon. During the morning hours, it's actually like this. So that's a very viable solution. This is the European model, and the red line is pure snow. A lot of this is ice as well. You can see some ice down here in Charlotte on the European. But the European model, again, Saturday night, the actual snow line is like this. There's the zero line. You can see that. So really, really heavy snow in southwest Virginia on the European, Kentucky, West Virginia, that sort of thing, spreading into Richmond and Charlottesville. And then by Sunday morning, December 9th, you can see the rain snow line just north of Richmond and between Lynchburg and Charlottesville. This is all heavy ice in here because look how cold, it's still below 32 degrees. This is all ice. So this would be a giant ice storm for the southern Shenandoah Valley, Greensboro, Northwest Virginia, that Hickory, that sort of thing. If this is right, I have no idea if it's right. I'm just letting you know this is what the model is showing. And this is the European Ensemble, which is a little colder. And again, notice most of the precipitation does not get north of DC, Baltimore, Philly on these particular model runs. That's not set in stone at all. Now, further down the road, the pattern collapses. This is the European Ensemble for December 14th. The polar vortex goes west to east, pulls out of Hudson's Bay, goes over towards Alaska. This allows strong Pacific jet to overrun the country, and the temperatures turn mild. Indeed, remember we talked about the MJO? Well, by mid-December, look what happens. It goes into phase 3 and 4. I circle those in red. You see them? See this here? Phase 3 and 4. There you go, right here. See it? Phase 3 and phase 4. What does that mean? Well, phase 4 is this. Big trough over western U.S., big ridge here. And that's a warm pattern. That's great for the California and the fires there, but it's terrible for winter weather levels on the East Coast. So after December 9th, things look like they fall apart pretty quickly. And even here, we just want to break it down by temperature anomalies and precipitation anomalies. Phase 3, phase 4 in December. Look how warm it is east of the Rockies. Not great. Now, that's not going to last. That doesn't mean winter's over. Okay, it's going to flip back after Christmas. I'm sure of that. But you have to be prepared for the fact that after this December 9th event, we might have 10, 12, 14 days of fairly mild temperatures. This is meteorologist DT from Weather Risk. I'll see you on the Facebook page and on the Twitter page.